Flammenphotometer, also has known as Photoelectric Flammenphotometer, is one of the most widely used laboratory devices used to measure the concentration of chemical elements such as sodium, potassium, calcium, lithium, and barium in the blood serum or other fluids. Plus its application in medical diagnostic, it's used in agriculture and industry too. The principle of this device is based on optical spectroscopy. As we studied in school chemistry laboratories, we know that every element on a flame burns in a particular color, and the intensity of the light emitted by the flame is proportional to the amount of the elements. The elements in group 1 and 2 of the Mendeleev's table are elements which this device is focused on. The electrons of these elements are excited for changing the energy bound by heat, which causes them to emit light, which a part of this light is visible. In this table, you can see the color of the elements on the flame, as well as the wavelength of light emitted in nanometers. As you can see, sodium burns yellow and its wavelength is 589 nanometers, and the potassium burns violet and its wavelength is 766 nanometers. Also, you see from the other elements, lithium burns as red, calcium as orange, and barium as lime green. And this is the block diagram of the components of Flammenphotometer. In fact, the fluid that we intend to measure the concentration of the elements in should be sprayed into the flame by an air compressor. You can see this compressor in where it's written compressed air supply. Lenses are used to concentrate the light emitted by flame, and the number of filters equals the number of elements that the device can measure them. In fact, each element has its own filter. The exhaust air from the compressor and the liquid of the sample are mixed into a chamber called mixed chamber and then sprayed on the flame. This image is chamber mixed with a large number of mechanical defects of the device belong it, and it needs service occasionally.